In the analysis section, at least for part 1, which is what we're doing before the end of the term, you have to include sufficient, relevant, quantitative and qualitative raw data to support a detailed and valid conclusion. The appropriate and sufficient data processing must be carried out with an accuracy required to enable a conclusion to the research. And then you need to be able to provide a conclusion that's consistent with the experimental data. Now, this is all I'm going to ask you to do for now. The second part of the analysis, which is to provide full and appropriate consideration to the impact of measurement uncertainty and a detailed conclusion, etc. These two bits we will talk about in a different video, and we will talk about it as part of your summer homework. Okay, so what you have to do and provide is sufficient quantitative and qualitative raw data, and then process that data to give you a nice graph, basically. Where do I want you to put your data? You need to put it in the template in this section called data collection and processing. And how you process your data must be explained in detail. Now, let me specifically list what you must include. You must include 6 readings for each, for your data. So, say for example, if you're doing the temperature of oil and its expansion, you would do 6 different temperatures, right? If you were doing the frequency of a guitar string, then you would have 6 different temperatures of a guitar string and then measure the frequency. So you need 6 instances of your independent variable. For each of those 6 instances, you would then need 3 trials, right? So you need to repeat your readings 3 times. You need to mention how you're avoiding errors. I would have a specific section for systematic and random errors. These are the following random errors I'm expecting. The wind's going to blow through the room and change the temperature of my guitar string. I'm going to close the windows, right? It doesn't matter how absurd, just let the examiner know that you understand what a systematic and a random error is and that you are taking consideration to try and avoid them. So have a section on errors and state your systematic and your random errors. You must take sufficient data, obviously. So, for example, this goes back to this idea of range. I'll give you an example of what not to do. Say, for example, you are doing the angle that you're throwing a hockey puck, and you choose to do 6 readings between 0 and 20. That's too narrow a range. You need to try and get your entire range. What is the maximum value you could possibly get? If you're doing temperature of oil, like, what is the maximum temperature that you can measure up to? That would be your top, and then your minimum, and then you would divide it by 6. So you'd go up into 10 degrees or 20 degrees, right? If you feel that you have a massive range, then don't do 6 readings. Do 10 readings, 15 readings. Do as many readings as you can. In fact, if you're insecure that your experiment is a little bit on the unsophisticated side, then take as many readings as you want, right? But the minimum is definitely 6. So careful with that range. You must definitely explore the minimum and the maximum possible range for your independent variable. You have to present your raw data in a specific table that only includes your raw data. Then make sure that you're using the appropriate significant figures. Remember, the appropriate significant figures are the numbers that you see on your instrument, right? So if you're using a thermometer that's measuring 0.01 of a degree, then all of your readings have to be to 0.01. And the column would be the same. The column of data will always be the same. I'll give you some feedback on that anyway. Outline your data methods, right? So once you've got your raw data, you might not have your dependent variables. You have to do some calculations to that, right? So what are those calculations that you have to do? The first calculation that you're going to have to do is to take an average of your 3 trials. Remember, that average would be on your processed data table, not on your raw data table. So your first section would be, this is what I'm going to do to average my results, and then any calculations that you do to follow up. Your significant figures of your processed data must be exactly the same as for the raw. So if your temperature was 0.01 of a degree and then you do something to square the temperature, then your temperature squared must be 0.01, the same amount of significant figures. Okay? And then I want you to draw a graph. Now that graph must be your independent and your dependent variables. Remember that the independent variable always goes on the x-axis for the IB. So your graph axes must be labeled correctly because your independent variable must be on the x-axis, your dependent variable must be on the y-axis. You must have the name of each axis and the unit of each axis correctly labeled. If you do a nice big graph, you'd be amazed how many people lose marks because they do these two tiny little graphs. And graph size and scaling appropriate. And that is all you have to do for now. Once you get to that point, you've completed your IA for this stage, and I can grade it and give you some feedback.